where you took the derivative of the derivative. For those of you who were not here last week, Tuesday, today is your first introduction to that. That was to prepare you for this week's and next week's lesson, and possibly when we come back from spring break. We are going to be taking derivatives of derivatives. Those are called higher order derivatives. So today is the 11th. Can you see that? No. Can you see that? We're going to be working on higher order derivatives. I passed out your example sheet for today. You will see on the bottom of your example sheet, you will have the scale. So level 2, level 3, level 4, and then the directions and expectations for all three of those levels. So level 2 will look like this, level 3 will look like this, it has some information on it, and level 4 will look like this, and some more information. So if you have any questions about what your levels look like, this is what you should refer to. Keep in mind, as I said before, these are just examples. This is not everything that it could look like. These are just examples. Okay? All right. So some notes before we get to this. Hold on. Okay. So vocabulary. Vocabulary / notation, etc. Remember that the first derivative, can you see that color? The first derivative is the slope of the tangent line to a curve. Yes, we're going to go back to tangent lines in a couple of weeks, so wow, that was very loud. We're going to go back to tangent lines in a couple of weeks, but we need to remember this. The notation for that is f prime of x dy dx y prime. So these are just examples of the notation. If you notice, we only have one apostrophe, one like little dash. This denotes the first derivative. So all of these dashes will be the first derivative. Yosari, you have to go down to 120. Last week you were taking the derivative of the derivative. This is called the second derivative. The second derivative is really just the derivative of the first derivative. So last week, if you were here, you saw that we took the derivative of the derivative. We don't call it that. We call it the second derivative or third derivative, which we'll get to later. The notation. We have multiple notations. We can have f double prime of x d squared y by dx squared. Excuse me. Y double prime. So all of these are notations for the second derivative. And you can tell it's the second derivative by these doubles. The double dash, the square, the square. These are all the second derivative. Any questions so far? For anything else greater than 2, I'm sorry, greater than 3. No, greater than 2. Greater. Can't fit that. So third derivative, fourth derivative, 50th derivative. No, I'm not going to make you take the 50th derivative. The most I will go is fourth derivative. We'll use fn of x, dn y, dxn, where n is the, good morning. Nope, not that one here. The order of the derivative. So third, fourth, etc. We can't use, this is not a non-example, meaning we can't use it. Can you see that color? Okay. We cannot use y cubed. We cannot use y to the third power to do the derivative, or h to the third power, because this implies that this is an exponent. So we can't use this. We can only use this for 3 and higher. Does that make sense what I said? We can only use this for 3 and higher. We can't use this. When you're done, take out the example sheet. We're going to do some examples. I'm going to show you what it looks like. We're going to do some practice, and then we're going to have a 2-question exercise. Give me 1 second. Ready? 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 Okay. All right, let's look at example 1. Example 1 says find the second and third derivative. So we have f of x is equal to 9x cubed minus 7x squared minus 9x plus 10. So this is just our function. We need to find the first derivative, which means that we need second and third derivative. Before we find the second derivative, we need to find the first derivative. So find the first derivative. So this is just power rule. I'm going to multiply and subtract 1. That gives me 27x squared minus 14x minus 9. Did I make a mistake, or is that right? No response. I'm assuming it's right. So this is the first derivative. But we're not looking for the first derivative. We're looking for the second and the third derivative. So we need to do it again. Am I going too fast? Are we sure? Okay, then I'm going to keep going. So what I'm looking for the second derivative is I'm looking for this notation, because this is one of your standards, the notation. And I know it's going to be the double derivative because of the 2 dashes. So that's one of your standards, is that you need to make sure that your notation is correct. So I'm going to use the power rule again because this is just polynomials. So I'm going to take 27 and multiply by 2. That's 54x minus 14. This is your second derivative. Any questions? Am I done? Why am I not done?
Third.
We need the third derivative. The directions say to find the third derivative. So the third derivative will be f triple prime. This is read triple prime because of the 3. So again, this would be the notation. This is what I'm looking for. If you miss the notation, you will not get, if you do not write the correct notation, you will not get that points for that question. Now there are 2 standards. There's the notation and the actual derivative. So I'm just going to use the power rule. This is the third derivative. I'm done. Questions? Questions? Yeah. Let me finish. We only have one other example, then you can go to water. I see people still writing, which is fine. I'm just going to move up. Is that good right there? For those of you still writing? Okay, let's look at example 2. We have y equals 12 cosine x.
Wait, that's the answer?
Yeah, oh, yeah, sorry. This is the final answer. This is the second derivative, and this is the third derivative. That's it. Okay. So we need to find the first derivative, which is y prime, or we can use dy dx. Remember that the derivative of cosine, of a cosine, so if we have y equals a cosine x, the derivative of that is negative a sine x. Negative a sine x. What does a stand for in this problem? 12. So what am I going to have to do to the 12 to get the derivative? Negative. So make it opposite. In this case, it's positive. The opposite of a positive is a negative. So it becomes negative 12 sine x. Any questions? This is the first derivative. I'm not done because we need what? Second and third. Am I going too fast? Okay. So the second derivative would be d squared y by dx squared, or y double prime. Either of these will get you your points for the notation. Either of those will get you the points for the notation. So remember that the derivative of a sine x is a cosine x. So do I have to change this negative? Do I have to change the negative? Does this tell me to change the negative? No, I don't need to. So it's going to be negative 12 cosine x. This is the second derivative. Questions? Am I done? No, because I need the third derivative. D cubed y by dx cubed. This is the only notation for a equation for 3 and higher. You cannot use, I'm sorry, yes you can. No, you cannot use y cubed. You cannot use y cubed. So I'm going to take the derivative of negative 12 cosine. I'm going to go back here. I need to change the sign because it becomes opposite. So that becomes positive 12 cosine x. And this is my third derivative, and I'm done. I found my second derivative and my third derivative. Questions?
Isn't that seven?
Yes, it is. Can somebody put a tally mark up there for me being wrong? Make a mistake. What am I at right now, by the way? How many mistakes are 16? Ugh. I'm gonna make a goal to not have that many next semester or next quarter. Questions? Fabian, go. Okay. If there are no questions, you have 4 problems. 2 on the front, 2 on the back. You need to find the second and third derivative. After you're done, come get it checked and get your exit ticket. If you are not done by, we'll say 8:52, we're going to stop you and you will need to take your exit ticket. Are there any questions? Okay. You can work in your groups. Just make sure that you are working. Is it signed in, Fabian?